Hi there, my name is Sailesh Bhatia and I am from eSkill Point. At eSkill Point, we help you to learn on your own certain skills which would help you to score or get you better in your academics. Now, today's class is on Pythagorean triplet. We have learned about the Pythagoras theorem when we were in class 7th and 8th. In fact, you would have learned about the right angle triangles, isn't it? Let's move ahead. So, do you recall what you had learned in your class 7th and 8th on Pythagoras? And how much do you know about right angle triangle? You should be aware that the Pythagoras theorem works only on the right angle triangle, and the theorem itself uh, needs a right angle triangle for the conditions to be met. Okay, now of course this is a little too basic for you. You are aware of what these triangles are. The first one is an equilateral triangle, and the one in the center is actually a right angle triangle. And the other one, of course, is a regular triangle. So acute triangle. It is not even isosceles. I may not think about it. So the definition of a Pythagoras theorem is in a right angled triangle. You can see a right angle triangle on the top. PQR, where Q is 90 degrees and PR is the hypotenuse. Now, the square of the hypotenuse is equal to the sum of the squares of the remaining sides, which means when I'm talking about this theorem, I'm saying that PR square, the length of PR square is equal to PQ square plus QR square. As simple as that. So we have three numbers that we get, and a lot of problems are solved using this formula. So let's go back to our title, the Pythagoras triplets. The triplets are basically a set of natural numbers, and if the square of the largest number, now here the largest number definitely would be the hypotenuse, is equal to the sum of the squares of the remaining two numbers, then the triplet is called a Pythagorean triplet. Again, the formula that we saw on the triangle PQR, okay, we talked about, a right angle triangle. So looking at this drawing here, of course, so here he's saying this x square equal to y square plus z square, where PQ is x, RQ is y, and PR is z. Now it's as simple as that. Now when this condition is met, the three figures, the three numbers that you get are Pythagorean triplets. So nothing very difficult to learn about, and you get a few marks in your 10th standard. It's good to remember, and the questions generally are asked, find out if these three numbers are Pythagorean triplets. So you need to use them in the formula. They have different ways of tricking you, and they will sometimes give you square root numbers. So if it works, yes. So again, I repeat myself, that the square of the largest number is equal to the sum of the squares of the remaining two numbers, then the triplet is called Pythagorean triplet. Let's move ahead with an example. In this example, we have three numbers, 11, 60, 61. Obviously 61 squared, the largest number is 3721, 60 squared is 3600, and 11 squared 121. And if you add up 11 square and 60 square, we do get 61 square, which is 3721. So we can comfortably, confidently say that 11, 60, and 61 are Pythagorean triplets. So this is the way you would write. The square of the largest number is equal to the sum of the squares of the other two numbers. Therefore, 11, 60, 61 is a Pythagorean triplet. Now, for your benefit, for your testing purposes, I have given you some numbers here. 3, 4, 5. That's very easy, isn't it? Don't you think? What is 3 square? 3 square is 9, 4 square is 16, and 5 square is 25. So you say that 9 plus 16 is 25, which is actually correct. So 3, 4, 5 is a Pythagorean triplet. For the rest, feel free to experiment and try it out. And also don't forget to do the exercises in your textbook. Thank you and thanks for watching. Don't forget to subscribe. We'll be coming with much more smaller tidbits of information which will help you to improve your concepts. These are small videos that won't take a lot of your time, but at the same time will give you good marks for you to earn in your exam. Thank you for watching. Take care and bye.